this video, we're continuing our discussion of object-oriented programming and encapsulation. To recap, encapsulation is the process of keeping the implementation details of an object hidden. What I never did really do was make a case for encapsulation. Why is encapsulation so important? Why is it one of the major tenets of object-oriented programming? Well, I can think of at least two reasons off the top of my head. The first one is that object-oriented programming helps you write applications that are more easily maintainable in and of themselves, but they also help you with reusable code. So if you write a class for one application, assuming that you write it correctly, you could use that same class in other applications that require similar functionality, which can save you a lot of time. But the classes have to be written in such a way that there is a low degree of coupling between all of your classes. Coupling in the context of software development means that the objects know way too much about how each other work internally, and as a result you can't easily break them apart. So they have all these interdependencies, and so you want to try to achieve low coupling within your application design, and that phrase low coupling, will come back to that often, especially as we get into more architecture type topic matter. But to kind of use the analogy that we used earlier in the day, with the paper, with the pencil, and with the person writing, if you were to super glue all those together, each one of them lose a little desirability, a little bit of usability, because now they're all single-purposed. You can only write on one single sheet of paper with one pencil. Certainly that's not something that we would do in the real world, and so we would try to achieve that same separation in our own code as we write it. So it's impossible for you to be completely to write classes that are completely independent of each other. Often you're going to be able to reduce coupling but not eliminate it completely. But encapsulation is the thought process that you go through to help reduce the degree of coupling that your objects rely on. Okay, so secondly, another reason why encapsulation is such a big deal and why it's so important is that by hiding the implementation details and forcing your objects to work only with each other via their interfaces, their public interfaces. In other words, through public fields or public methods. If you have to change the way that the object or the class works under the hood, it shouldn't affect any of the objects that are relying on those public interfaces. So in the case of a car, it doesn't really matter which car I get into. They all have a steering wheel, a gas pedal, a brake, little turn signal clicky thing. I still don't know the proper word for that. But at any rate, how it operates under the hood, it doesn't matter to me whatsoever. The fact that I can get into any car and it still works is what we're talking about here. And so when you do make changes under the hood, it doesn't affect those other objects or code that rely on those objects. Okay, they're little black boxes, and they remain unaffected by any changes that go on internally within a given class. Okay, so we're all for encapsulation, right? Makes total sense. Sounds like a time-tested, proven method for writing software. And in the previous video, we looked at encapsulation in terms of creating methods. And now we're going to look at encapsulation in terms of properties and fields. So when we started today, we said that fields store the state of a given object, or another way of saying it is perhaps the current state of the attributes that describe an object. We said that some things, like, for example, the mileage and the speed, those things may change. They're still attributes of an automobile that could possibly change over time. Other attributes might stay the same regardless, the vendor information number, the make, the model, things of that nature. But regardless of whether those are kind of static or if they're constantly changing, fields describe the unique qualities or the current state of a given instance of a class. So take a look at the code that we have here. This is the example from yesterday. We have our fields defined. We'll pick on two in particular. The make, for example, public string make. And then also we have public integer speed. The problem with using fields the way that we have them defined here is that you can put the object into an inconsistent state by setting its properties to nonsensical values. It's a form of breaking encapsulation. The client of your object knows way too much about the inner workings of your object, of the class. So if you recall what happened in the previous video, quite innocently and by accident, at some point we allowed the car to go -3 miles per hour because our decelerate method didn't check to make sure that you couldn't go below 0. So we accidentally put the my car object into an invalid state. Ideally, that would never happen. When those things happen, they cause exceptions potentially in your code. So how can you stop that from happening? How can you protect your fields from being set to improper values? Well, the answer is a common answer that you'll see when working with object-oriented programming. The solution to most problems is to insert another layer of abstraction. And what does that really mean? Well, in this particular case, it means that we're going to need to insert something between the field and the code that needs to use the field. And in this case, we're going to use something called a property. So the first step would be to make whatever field it is, or all of our fields, private. We'll talk about private and public later. Quite honestly, I think that by the end of this video, you'll have a pretty good sense of what the difference is between private and public. So as we go along, you'll probably see that, but we'll talk about it more formally a little bit later on. All right, so the first step is to make your fields private. And then the second is to create public properties. And a property is like a method. It's a special kind of method that it has really two sub-methods inside of it. One for setting a property, and then one for getting a property. So one, when you want to try and use the equal operator, it will call the set. And whenever you try to reference a given property, it'll use the get version of the property. This will make sense in just a minute. And then the third thing is that from that point on, any code that would formerly have used the public fields will now use the public properties. The properties then become something like a guard. They become a gatekeeper. They don't allow anything else to have access to the fields, since having access to the fields could pose a potential threat to the stability or the integrity of the object. Okay, so let's see this in action. What I want to do is this. Let's take make, for example. And we'll use a very simple example to start off with, and you'll be confused by the end of it, and I'll explain. All right, so we're going to take public string make and make that private. This next step is to write some code. Specifically, we're going to do this. The other step is, by convention, I'm going to use a lowercase m in the private field and use the capital M in the public property. Talk about naming conventions again a little bit later. All right, so in this case, we're just going to return, and we've used the return keyword. It sends something back, right? And that's exactly what we're doing. We're going to send back the value that's currently stored in our private field. Here, we're going to set the value, the private field of the value of the private field make, equal to whatever's been passed into using the equal operator. So in this case, value. Okay, so that's half of our battle. Oops. Don't forget the semicolons at the end. All right, so then the other part of it is taking a look at the code that actually used our public field. Now it's a private field, but we've instituted a public property that looks exactly the same. So make, you can see this line of code, nothing changed. Why didn't anything change about it? Well, because we named them the same. If I had changed the name of make to maker, we will see a problem here. Okay, so we'd have to set make to maker. Now when we run our application, I would expect that, unless I have introduced some sort of bug. Yes, we have another make we need to turn into maker as well. And now let's run it and see. Okay, so it all works, right? And you might be saying to yourself, well, why did you go through that entire exercise? Just so you could rename, the field to a property? What did this really accomplish for us? Well, admittedly, in this very simple example, it's not readily obvious. But let's expand this example a little bit, and maybe it'll start becoming obvious why this is important. And this example might be a little contrived. Just stick with me, you'll see. Hopefully the real value of it will come shining through, even though this is a silly example. Okay, so take a look at what we did here. We're only going to accept make if it's Oldsmobile or Toyota. That we're restricting it to only be set to those two values. If it's anything else, then we're going to throw an exception, which is the equivalent of what we saw earlier with exceptions we encountered accidentally. When we put, for example, the Ray index out of range. Here we're throwing our own exception, calling it a not a valid maker exception, okay? And so whenever we attempt to use our application again, you'll still see no change because we're setting it to Oldsmobile. But what if we were to set this to BMW, for example, and then run our application? We're going to get an exception, and it's a not a valid maker exception, okay? And that works exactly like we would anticipate. So that's one valid use of using a property to restrict the values of a field, to protect that field from being set to something our business rules say would be impossible. For our particular application, we may never allow more than the make to be set to 3 or 4 possible values. This is how we enforce that, okay? So then let's try another example and expand on this idea just a little bit. And here we're going to pick on speed. So I'm going to do 2 things to speed. The first thing is I'm going to set it to a lowercase s, and again, that's a convention, a naming convention that we didn't talk about previously, but typically whenever anything is private, we're going to set it to a lowercase. Whenever something is public, we're going to set it to an uppercase. Okay, so again, private and public, what is that again? You'll see in a minute. It'll become more obvious to you. Okay. Here we're going to go public int speed. Let's call it current speed. Just to prove that we don't have to name it exactly what the name of the private field is. And here we're going to just get our templated code set. And this is the basic format for creating a property. Here we're going to return the speed field, and here we're going to set do some customization. All right, so what have we accomplished here? We are limiting the possible values that can be set for speed, or for current speed, or actually the speed private field, right? So speed is either going to be between 0 or 110, but it cannot be less than 0 or greater than 110. If, however, it falls within those acceptable ranges, then go ahead and just set speed to whatever the consumer of our object is currently attempting to set the value current speed to. Okay, so this is going to affect a couple of things. Most notably, here within our auto.cs file, we're going to have some problems with the three methods we wrote in the previous video. Speed, there's no longer a definition for it. We currently have speed with a lowercase s, or we have current speed with capital C and capital S. So what we'll need to do is either do this, which accesses the private field. Do you see a problem with this? Well, there may not be a problem with this per se if you're being careful, but in the previous video, accelerate and decelerate were the very reasons why we encountered the problem in the first place. We could duplicate the code, or we could just assign the code specifically to the accelerate and decelerate methods. We don't want to do that, however. So by convention, what we want to do is always use the property. Think of the property as the gatekeeper to the private field. So we always want to use the public property in order to access it, because it will then delegate the job of the set to our property, and we'll do all the checking, the boundary checking, and things of that nature there. So we're going to do the same thing here: current speed and current speed, and then one more time down here, current speed. All right, so we fixed at least the problems, I think, with the auto.cs. However, we still have problems with program.cs. How can we fix this? Well, we're going to have to change speed here to current speed. Now, let's back up a little bit. Say I wanted to actually try to access the private member variable. I'm going to type in lowercase s. Speed is not defined, at least as far as IntelliSense is concerned. Now, we can override that and attempt to go ahead and use lowercase speed, but when I attempt to do that, I'm going to get a build error, and it says that lowercase s in speed is inaccessible due to its protection level. What does that mean? Since we made it private, we are basically saying this is an implementation detail. Nobody needs to know about what goes on in the black box. All you need to know, if you need to access the speed, what you need to do is access it via the current speed property, which is public. You can use public. Private means it's private and internal. Its implementation details are private to all other classes, all other code. Okay, that's the basic difference. That is called an accessibility modifier. Perhaps we should revisit this and give it its due. I just felt like I needed to cover it right now so you could kind of see it in the context of trying to use it here. So let's go back to current speed. And I think we're going to hit up against this again, maybe a little bit later. No? Okay. That's all we needed. And now let's run our application, and it should... Whoops. We need to fix that problem, right? Let's go ahead and turn this back to Oldsmobile. And now we can move on. Yeah. All right, so that works. But what if we were to do something like this? I'm going to comment out these two lines of code. And I'm going to accelerate to 5 plus 6 plus 2 plus 110 plus 3. So we're going to go way over the 110 mark. Let's run the application. Well, actually, let's do this. Whoops. This. So we can see what the current speed is. Okay, I see what I did. Let's just ignore that. And let's just move this line of code down here. This would better represent what we're trying to accomplish. There we go. Okay, so you can see now my current speed is only 110, even though we attempted to set it much higher than 110 using the accelerate method. Okay, so that makes perfect sense, right? Now let's do the opposite. Let's get that back down to 10, and let's reintroduce our decelerate method, and we'll decelerate by 100 just to be silly and just to make sure we cover our bases here. So can we go like negative 90 miles an hour? Well, let's run the application and see what happens just to confirm. And the current speed is 0. It probably should realistically be a lot less than that. However, again, just to reiterate, this condition right here checks to make sure that whatever we're setting it to doesn't fall below 0. If it does, set it to 0. Okay? All right, so just to kind of recap, properties allow you to check the operation of a setting before that setting or that field is allowed to actually be set. It's a layer of abstraction. It's something you put in the middle between the client code and the actual field itself. If the client of the object tries to set the field outside of the boundaries of what is acceptable, the property is going to step in and stop it and raise an exception to the client and say, no, you can't do this. Or it has the opportunity to kind of plug in and set that value to something that's more meaningful or within normal boundaries. Either way, that's for you to decide within the business rules of your application. All right, so that pretty much covers our use of fields and properties, and we can see how encapsulation is enabled by using properties. We also looked at public and private. So we have a lot going for us here in this example and in this video, and we're going to build on that by finally talking about the new operator, which we've been referencing for a couple days now, and I've been telling you be patient, ignore what I'm saying. Well, now we're going to get into the thick of things. So we'll see you in the next video. Thank you.